Welcome to the DIY Honda Garage channel. DTC P2413 indicates an EGR, exhaust gas recirculation system malfunction, within the Honda HR-V model from 2016 to 2022. The EGR system plays a critical role in reducing nitrogen oxide emissions by recirculating a portion of the engine's exhaust back into the intake manifold. This allows for lower combustion temperatures, reducing pollutants emitted into the atmosphere. The main components involved in this diagnostic trouble code, DTC, include the EGR valve and its position sensor, which monitor and control the flow of exhaust gases. The EGR valve is typically located on or near the intake manifold, and the EGR position sensor is mounted on the valve itself. A malfunction in this system can cause poor engine performance, increased emissions, and potential engine damage. Thorough troubleshooting is essential to identify the root cause of the malfunction and restore proper functionality to the EGR system. The error code P2413 is specifically related to a malfunction in the EGR system, which mainly includes the EGR valve and its position sensor. The EGR valve is responsible for recirculating exhaust gases into the engine's intake, contributing to a reduction in harmful emissions. The position sensor, typically integrated with the EGR valve, continuously measures the valve's angle and relays this information to the powertrain control module, PCM. It's located on the valve assembly, near the intake manifold, making it readily accessible for inspections. When issues arise, such as a lack of response or sporadic readings from the position sensor, it triggers the P2413 code. A thorough understanding of each component's functionality and location is vital for effective troubleshooting. Several potential causes can trigger the P2413 DTC. The most common is a malfunctioning EGR valve, which may be stuck open or closed, preventing proper exhaust flow. Alternatively, the EGR valve position sensor may fail, leading to inaccurate readings of the valve's position, ultimately affecting engine performance. Wiring issues are another significant cause, including open circuits, short circuits, or poor connections, which can prevent signals from reaching the PCM from the EGR system. Lastly, it's important to consider software issues within the PCM, which can also affect system performance. Identifying the root cause through methodical checks is crucial to resolving this DTC effectively. The symptoms accompanying the DTC P2413 can vary, but often include noticeable engine performance issues, such as rough idling or decreased acceleration. Drivers may also observe increased emissions output, which could lead to failing emissions tests. If severe, prolonged malfunctioning of the EGR system can potentially cause engine damage due to excessive temperatures or knocking. Warning lights, particularly the check engine light, are frequently triggered, alerting the driver to a potential engine malfunction. Therefore, prompt attention to these symptoms is crucial for preventing further damage and maintaining optimal vehicle performance. In the first step of troubleshooting DTC P2413, start by turning the vehicle's ignition to the on mode without starting the engine. This action is crucial as it powers the onboard diagnostic system. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs stored in the PCM. This ensures that no residual codes interfere with current diagnostics. After clearing the codes, start the engine and hold the RPM at 3,000 for a few minutes, during which time the radiator fan should engage. Finally, allow the engine to idle down after this test. The purpose of these initial checks is to initialize the EGR system and prepare the vehicle for a detailed EGR test conducted later using the HDS. For the second troubleshooting step, Begin by turning the vehicle's ignition off to reset any applied settings. Once the engine is off, switch back to the on mode to reactive the system. The next phase involves using the HDS to check specific parameters, particularly those concerning the EGR valve position sensor. This includes assessing the voltage readings emitted from the sensor to ensure they align with specified thresholds. In this case, you are looking for a voltage reading that is near 0 volts to confirm functionality. Depending on whether the readings match expected conditions, you will either proceed to the next step or revert to potential wiring issues or internal problems. In this step, turn off the vehicle again to ensure a safe working environment. Disconnect the EGR 5P connector, which is vital for isolating the EGR system from the rest of the circuitry. Then, with the ignition set to the on mode once more, measure the voltage across the specified test points between the second terminal of the EGR connector and a solid body ground. A reading of approximately 5.0 volts is expected to indicate that the VCC2 line is functioning correctly. If you do not observe this voltage, you will need to investigate further, checking for potential short circuits or wiring malfunctions that could impede EGR valve function. For the fourth step, ensure the vehicle is off before conducting further checks. Jump the SCS service check socket line with the HDS for system testing. Once this is completed, disconnect the PCM connector B 51P to isolate the powertrain control module during diagnostics. Check for continuity between the specified test points, specifically the terminal at PCM connector B B29 and the corresponding terminal at the EGR valve connector, number 2. If continuity is present, it indicates that there are no breaks in the VCC2 line. Should continuity fail, it strongly suggests there is an open circuit in the wire leading to the EGR valve that requires immediate attention and repair. Step 5 again involves turning off the vehicle and preparing for testing. You'll jump the SCS line with HDS to facilitate continuity checks. Disconnect PCM connector C 51P to isolate it from the circuit during the reading. At this point, check the continuity between the designated test points of the EGR 5P connectors number 4 and body ground to ascertain the condition of the EGR L wire. A continuous reading indicates that the EGR L wire is in good condition, while a lack of continuity suggests there is a short or open that requires further investigation into repairs specifically to that wiring harness. In this step, you will conduct a final continuity check on the EGR L wire. Ensure the vehicle is in the off mode for safety. Establish connections for testing between the specific terminals located at PCM connector C C23 and EGR valve connector number 4. This continuity check aims to confirm that there are no cuts or breaks in the wiring. If continuity exists, it signifies a healthy wire and will allow you to proceed to the next troubleshooting step. If continuity is absent, an open must be repaired to ensure proper EGR system operation, making it a crucial part of the diagnostic process. Step 7 involves a critical check of the EGR valve position sensor's internal circuitry. Begin by ensuring the vehicle is off and the EGR 5P connector is disconnected. Measure the resistance between test points located at the EGR valve connector, number 3 and number 4 at the valve side. You are looking for a resistance measurement of 100 kilowatts or more, which indicates that the internal circuitry within the EGR valve position sensor is intact and functioning properly. If the resistance is below this threshold, it signifies that the sensor is faulty and should be replaced in order to resolve the DTC and restore EGR function. In the 8th troubleshooting step, you will need to recheck the resistance of the EGR position sensor, but from different test points. Ensure the vehicle is off, and if not already done, disconnect the 5P connector. This time, measure the resistance from number 2 to number 4 on the EGR valve side. Similar to the previous measurement, you're looking for a value of 100 kiloohm or more. If the resistance falls below this, it indicates a failure in the position sensor, necessitating a replacement. Accurate resistance measurements are imperative for confirming the operational integrity of the EGR valve and its ability to manage exhaust gas recirculation. For step 9, ensure that the vehicle is turned off to safely access the wiring. Start by jumping the SCS line with the HDS to begin testing for potential issues. Disconnect PCM connector C, 51P, if this has not been done yet. Measure for continuity between the test points of PCM connector C, number 5, and body ground. A positive reading indicates a short in the EGR wire and will require repair. If no continuity is present, this means that the EGR wire has not shorted, and further diagnostics or steps will be needed to isolate other potential issues within the EGR system. In troubleshooting step 10, you will continue to examine the EGR line for continuity. This time, check the wiring between specific test points at PCM connector C, number 5, and EGR valve connector number 5. Ensure that the vehicle's ignition is off before testing. If continuity exists, the EGR wire is functioning properly, and you can move forward with the troubleshooting process. Conversely, if there's no continuity evident, it is imperative to locate and repair any open circuits in the wiring harness to restore the correct EGR system operation. In the 11th step of troubleshooting, you focus on the PG line for continuity checks. With the vehicle in the off-lock mode, verify the connection between test points located on the EGR valve connector and body ground. Ensuring that continuity exists demonstrates a good PG wire, which is vital for proper EGR functionality. If continuity is absent, repair any breaks or opens found in this wire, as it is essential to facilitate the operation of the EGR system and help alleviate the DTC P2413. Ensuring each line is fully functional is key to a successful repair outcome. For troubleshooting step 12, start by reconnecting the PCM connector C, 51P, to restore functionality. This prepares the EGR valve circuitry for operation. At the EGR valve side, use a jumper wire to connect terminal A of the EGR valve 5P connector, number 5, to the battery positive terminal. Then start the engine and let it idle while also connecting terminal A to the battery negative terminal using a jumper wire. This test checks whether the EGR valve opens correctly. If the engine stalls or idles poorly during this procedure, it implies the EGR valve is functioning as required. Consider updating the PCM software if applicable, or substituting a known good PCM if other tests continue failing. In the final troubleshooting step, start by turning the vehicle off to safely remove the EGR valve without risk of electrical shock. Remove the EGR valve carefully and utilize throttle plate cleaner to thoroughly clean both the intake manifold EGR port and the interior passages of the EGR valve itself. This cleaning addresses potential restrictions caused by carbon buildup, which is a common issue affecting the EGR system's operation. Once the cleaning is complete, reinstall the EGR valve, reconnect all electrical connectors, and ensure the installation is secure. After this, turn the vehicle on and reset the PCM with the HDS, allowing it to relearn idle parameters and perform the EGR test to confirm successful repairs. After completing all troubleshooting and repairs related to DTC P2413, it's important to verify that the EGR system operates correctly. Run the EGR test using the Honda Diagnostic System, HDS, one more time to assess functionality. Monitor for any new diagnostic trouble codes that may have arisen during testing. If the results are satisfactory and no additional codes are found, the troubleshooting is deemed complete. Document all repairs made and tests conducted for future reference. This verification step is vital as it ensures all systems function correctly, avoiding potential recurrences of similar issues down the line. To prevent future issues related to the EGR system, performing regular checks is essential. Routine inspections of the EGR valve, position sensor, and wiring can help detect anomalies before they lead to diagnostic codes like P2413. Keeping connectors clean and free from corrosion is also critical to maintaining good electrical connections. Properly functioning connectors ensure clear signals are transmitted to the PCM, preventing misdiagnoses. Additionally, keep the vehicle software updated, as multiple performance issues can often stem from out-of-date programming. Implementing these preventive measures can prolong the life of the EGR system and enhance overall vehicle performance. In conclusion, DTC P2413 signifies an EGR system malfunction, which can stem from various issues including valve function, sensor performance, and wiring integrity. Proper and methodical troubleshooting steps are crucial for accurately diagnosing the root causes of this error code. Thorough inspections, measurements, and potential cleaning or replacement of components can resolve the issue effectively. Furthermore, adopting a regimen of regular maintenance practices will help to prevent similar occurrences in the future, ensuring the longevity of the EGR system and optimal performance. Understanding and addressing these components ensures a reliable and emissions-compliant driving experience for Honda HR-V owners. Please like and subscribe to the channel. See you next time.